That's going to be the last part of this chapter here. It's going to be on hybridization and sigma pi bonds. And I'm going to make this pretty brief and to the point in terms of what you really need to know. So hybridization is when like an S and P or P and D orbital overlap and form what's called a hybrid orbital. So you have S orbitals that are spherical in shape. So S's are kind of a spherical shaped orbital. P's are kind of a, I don't know what you call them, but kind of a lobe shaped. So they're going to hybridize and make what's called like an SP hybridized orbital, where you have that lobe. So you have like an S and part of a P, where you have this orbital that's intermediate between an S and a P in terms of energy. So if we look at this carbon right here, okay, just the carbon, not the hydrogens, just the carbon. Carbon ends in 2s, 2 electrons, and then 2p with your 3p orbitals. It only has 2 electrons in there. So if this was the case, carbon would typically only form 2 bonds. Since those are paired electrons, those would not bond. It would only form 2 bonds. Well, we know carbon almost always forms 4 bonds. So as you know, or maybe you don't know, but this electron here tends to move up here and fill that open orbital. So what you now have formed are what are called sp hybridized orbitals. And we've made 4 of them. We have what's called 4 sp hybridized orbitals. Okay, and there's 1 s and 3 p's that make up those orbitals, so it's called sp3 hybridization. So really the easy way to do this, okay, there's going to be different amounts of hybridization, and there's more extensive than this, but there's going to be what's called sp hybridization, sp2, and sp3. That's all we need to know. Now there is some dispute about whether there's an sp3d, sp3d2. We're not going to go into all that. We're going to stop right here because that's all that AP asks us to know at this point in time. Okay. And here's what we look at. SP means there are 2 electron domains around the central element, okay, or 2 regions of electron density, whether that's a double bond and a single bond, a bond and an unshared pair, but there's 2 electron domains. This means there's 2 plus 1, 3 electron regions, and this one means there's 3 plus 1, the 3 on the P plus the 1 on the S, 4 electron regions. That's all you really got to know. So let me go to the next page and show you what I mean by that. If we look at this carbon right here, this carbon, there's 4 electron regions, 1, 2, 3, 4. So that is sp3 hybridization. 3 plus 1 means 4. There'd be 4 hybridized orbitals. If you look at this carbon right here, double bonds just count as 1 electron domain or 1 electron region. So you've got 1, 2 around that. This carbon is just sp hybridized. 1, 2, 1, 1 adds up to 2. Simple as that. Our oxygens, okay, if we look at our oxygens on this, oxygens have unshared pairs count also. So you have 1, 2, 3 around the oxygen. So the oxygen is sp2. 2 plus 1 is 3. If we look at this down here, this nitrogen has 1, 2, 3, even an unshared pair has 4 electron densities around it, so it is sp3 hybridization. Our nitrogen here, unshared pair, another electron region. So this just counts as 1 electron region, 1 electron region. That would just be sp hybridization on that nitrogen. Up here, this oxygen's got 1, 2, 3, 4 areas of electron density, so we call that sp3 hybridization. 3 plus 1 is 4. This one, this oxygen, would have to have an unshared pair in there. Sorry, I forgot to put that in there. But it would have 1, 2, 3 areas, so that oxygen would just be sp2, 2 plus 1. This oxygen would have unshared pair, and bonding area there, so that'd have 3. So that oxygen at the end would be sp2 hybridization. All right. In terms of sigma and pi bond, sigma is 2 s orbitals overlapping. A pi bond is 2 p orbitals overlapping. Pretty simple. Single bonds are always sigma. Always sigma bonds. A double bond, so let's go single bond, so must be XX, 2 elements bonded. If 2 elements are double bonded, 1 sigma, 1 pi bond. If 2 elements are triple bonded, 1 sigma, 2 pi. So whenever there's a bond, one of them is always a sigma. The rest are pi's. One's always a sigma, the rest are pi. That's about all you really need to know here. So if I asked you the hybridization of each element other than hydrogen here, carbon's hybridization, it's got 1, 2, 3 electron areas. That carbon up there would be sp2 hybridization. This carbon right here has 1, 2, 3 areas of electron density. It would be sp2 also. This carbon only has 1, 2 areas of electron density. This one would just be, let me do that. This carbon right here would just be sp hybridization. Same thing with that carbon. Our oxygen would have 1, 2, 3, 4 electron domains around it, so it'd be sp3 hybridization. If we count up sigma bonds, then let's circle the sigma bonds. Sigma, sigma. One of these two is a sigma, sigma, sigma. One of these three is a sigma, sigma. All those are sigma bonds. This would be a pi bond. These two would be pi bonds. So there's always 1 sigma bond, and the rest are pi bonds. If there's a double bond or triple bond, one is a sigma, the rest are pi. If there's single bonds, all are sigma. So pretty brief. That's all I'm going to tell you.